Hello, my name is Zachary Ono. So in this presentation, I will explain my second network architecture design, demonstrate my virtual lab setup using VirtualBox, and discuss the result of vulnerability scan performed with Greenbaum in a vulnerability manager. I will also highlight key security issues affecting both current and emerging network technologies. This network design follows a layered security approach, also known as defense in depth. Traffic originates from the internet and passes through an edge router and a perimeter firewall, which filters unauthorized traffic before it reaches internal systems. A DMZ is used to host public facing services such as web, email, browser servers, ensuring external access while protecting the internal network. IDS and IPS systems are placed after the DMZ to monitor and actively block threats. The internal network is further secured with a second firewall and segmented into departments using VLANs, while an air-gapped R&D network ensures maximum protection for sensitive data. On this slide, it shows the successful creation of Windows 11 virtual machine in Oracle VM VirtualBox. The configuration includes allocated memory, storage capacity, and processor settings required for optimal performance. At this stage, the machine is powered off, indicating that it is ready for initialization and further configuration, such as joining domain and participating in network activities. Here, the Windows 11 virtual machine is fully running. The desktop environment confirms that the operating system installation was completed successfully. This step is important because it validates that the virtual machine is stable and ready for use in the network environment, including testing, connectivity, domain integrity, and security assessments. On this slide, it demonstrates the process of joining the Windows 11 virtual machine to a domain. The domain name has been entered, which allows the system to become part of a centralized network infrastructure. Domain joining is critical because it enables centralized authentication, user account management, and policy enforcement across the network. This slide, this screen confirms that the virtual machine has successfully joined the domain. The system properties clearly display the domain name. Verifying integration. This allows the system to access shared resources, apply group policies, and be managed centrally by network administrators, improving both security and efficiency. On this slide shows the creation of a second virtual machine using Ubuntu Server. It includes configuration details such as memory allocation, CPU assignment, and storage capacity. Having multiple operating systems in the lab environment is important for testing cross-platform communication, network behavior, and vulnerability scanning across different systems. In the IP slide, this screenshot shows the IP configuration of the Windows virtual machine using the ipconfig command. It displays the assigned IP address, subnet mask, and default gateway. This confirms that the system has been correctly configured within the network and can communicate with other devices. The network connectivity slide. This slide shows successful communication between the Windows and the Ubuntu virtual machine using pig commands. Both systems send and receive packets with no loss and minimum latency. This confirms that the network configuration is correct and that the virtual machines are able to interact within the same network environment. This screen shows the green vulnerability manager dashboard, which provides an overview of scan task, report, and severity levels. This dashboard is important because it gives administrators a visual summary on network security status and help track vulnerability across systems. On the GVM target configuration slide, this slide shows the configuration of a new scan target in GVM. The target ID address and the port settings are specified to ensure the correct system is scanned. Accurate target configuration is essential to ensure that the vulnerability scan is focused and produces meaningful results. On this screen, this screenshot shows the vulnerability scan actively running using the full and fast configuration. The progress bar and logs provide real-time updates on the scanning process. This step demonstrates that the system is being analyzed for vulnerability such as an open port, weak services, and misconfigurations. On this slide presents the final result of the GVM scan. Vulnerabilities are categorized into high, medium, and low severity levels, along with CVSS scores and recommended phases. These results highlight weaknesses such as outdated software or exposed services, emphasizing the need for regular patching and vulnerability management. Second to the last screen, this screenshot shows the result of an Nmap scan used to identify open ports and running services. Several ports such as SSH, HTTP, SMB, and MySQL are open. These open ports represent potential attack vectors. If not properly secured, Nmap helps administrators understand network exposure, and identify possible entry points for attackers. So this slide, shows Wireshark, capturing live network traffic. It displays pocket level details such as IP addresses, protocols, and data, transmissions. Wireshark is used for monitoring network activity, troubleshooting issues, and detecting suspicious and malicious behaviors in real time. So in conclusion, we're going to talk about security issues. So modern network face increasing security challenges due to technology such as cloud computing, LOT devices, remote access systems. Many protocols still lack strong encryption, making them vulnerable to attacks such as interception and data breaches. Imagining threats like zero-day vulnerabilities and inside attacks further increase risk. This highlights the importance of layered security, continuous monitoring, and proactive vulnerability management. So in conclusion, this project demonstrates how combining secure architecture, segmentation, and security tools help protect and monitor network environments.